Let's consider independence test. This is the testing for cross table, contingency table. Let's look at what it is. In case of testing for contingency table, there are two kinds of tests, independence test, homogeneity test, but testing method is almost the same. Let's consider this example. Suppose you have 100 sample. You collect 100 sample. Be careful. Collect 100 sample, but check the two characteristics, whether they are men and women, or wearing glasses or not glasses. Considering two kind of variable, and you have two categorical data, and you check the frequency, we call it, this is contingency table or cross table. We are curious to know that whether gender and wearing glasses are independent or not. What does mean independent? If you're looking at this kind of data, it seems a male student, they wear more glasses because we have a 50-50, means same number of male and female, but they are wearing more glasses. In case of the lady, there are more lady who doesn't wear glasses. We call that these are related. I mean, man wearing more glasses, the woman doesn't wear glasses. There is some relation between two variables. Gender and wearing glasses are related. But is it statistically significant? That is, we'd like to check. What does it mean, the independent data? Suppose you have the same data, independent case look like this. There are 100 person, you have 60% of wearing glasses, non-wearing glasses. You have same percentage. Okay, this is 60, 40% of 50. You have the same percentage. What does it mean independent? Gender doesn't influence anything about the wearing glasses. That's the meaning of independence. How to check that visually? I mean, you can enter data like this. If you click this one, plot line graph, they're gonna show this. If you have some kind of relationship, you would have a cross. Okay? I mean, male has more percentage of wearing glasses. Female has more percentage of non-wearing glasses. That's the meaning of this cross. But we are curious to know, to check that. How can you do that? We compare the original these things is observed frequency. In case of independence, we call these are the expected frequency. Therefore, we calculate squared distance between observed frequency and expected frequency and add it whole. That's the test statistic. It looks like this. Here's row and columns variable are independent. That's the null. They are related. That's alternative. The test statistic, you calculate the squared distance and then divide by expected value. Okay. Well, it has a value 16.67. Our decision rule is this is chi-square test statistic, and you have to look up chi-square this degree of freedom. R is number of row, in our case is 2. C is number of column, that's 2. Therefore, you have to look up chi-square 1. The right tail 5 percentile is 3.841. If it is greater than this value, well, we have to reject. In our case, the test statistic was 16.67. It is greater than 3.841, therefore it is rejected. Well, in East and New module, you can do in this manner. Just enter your data, row and column in this manner. It's a 2x2 cross table. Then if you click execute button, they're gonna generate this chi-square distribution, chi-square with 1 degree of freedom, r-1 times c-1, it becomes 1. The test statistic is located somewhere else here, and the critical line is here, 3.841. Therefore, you have to reject. Let's have some formal definition. Suppose you have this kind of observed frequency, okay, row variable, column variable like that. How can you calculate the expected frequency? You calculate the proportion of this total. Out of n, you have this amount is t dot 1, the first column, second column, the sixth column. You calculate the proportion that is here. Okay, these are the proportion. On each total, you multiply this kind of proportion. That will be the expectation. Then you test that, calculate all sum of squares between observed frequency and expected frequency. Square them, divide by expected frequency. We check chi-square distance. Okay? But be sure the chi-square distribution for independence test, all expected frequencies are at least 5 or more. If not, you have to combine. Same thing true for goodness of fit test. Let's consider one more example. You have this kind of frequency cross table. There are 500 sample, and here are region, and here are beverage. They check the preference. Okay? So we have all different number on total. How can you calculate the expected frequency? The first thing you have to do is calculate proportion. Then the proportion multiplied to each total. If I plot this data, it shows like this. It seems there are several cross. That means they are look like related, but we'd like confirm that using the test of independence. As I said, you need to calculate some proportion related with each column, the total. Then multiply this proportion to each value, each row total. Okay? It will give you the expected frequency. We are talking, this expected frequency, that's independence case. And we calculate all kind of the squared distance between observed and expected, and divide by expected frequency. And you check that in this case we have 3 row, 3 column. Therefore, you are supposed to use chi-square 4 degree of freedom by looking up 5 percentile. Right tail is 9.488. But your calculated test statistic is larger than this one. Therefore, H0 is rejected. Now you can plug in this number in East and New module. Then this chi-square 4 distribution shows that test statistic is in the right corner, but here's critical line. Therefore, H0 should be rejected. Well, you can have a test of independence using East and module. Remember, if you have data like two categorical variable, you can have a cross table like this. At the frequency table, you can calculate this kind of thing. At the end of this output, they provide you the chi-square test value. So 1.667 degree of freedom. Y this 2 is R minus 1, R is 3, column is 2, therefore it's 2, and they provide you p-value, therefore you have to accept H0. Okay, this is for test of independence. Next class we are going to discuss test of homogeneity.